Okay, first term is a in the common ratio r. I want the nth term. So Tn is ar to the n minus 1. The power is always 1 less than the term number. I want to prove the sum of the first n terms is given by. Okay, so Sn, the first term is a. And then the next term I multiply that by r, so I get ar. The next term I multiply that by r, so I get ar squared, and so on, up to the nth, the last term, the nth term would be ar n minus 1, and the one before it would be 1 power less than that, so that's ar to the n minus 2. Then for a GP, what we do is we multiply the series by r, so on the left I got rsn, and on the right to multiply this one by r I get ar, that one but is ar squared, and so on. Multiply that by r, so add 1 more to the power, that's ar to the n minus 1, and this one multiplied by r is ar to the n. Now what we do here is subtract these two series. So on the left I got Sn, take away Rsn, and on the right when I subtract, if I look at these pairings, they will cancel out when I subtract, so I'll only be left with the first term on the top line and the last term on the bottom line. So it'll be a minus ar to the n. Factorise the left hand side, Sn is a factor, so that'll be 1 minus r, and on the right hand side a is a factor, a outside is 1 minus r to the n. And then to get Sn on its own I divide by the 1 minus r, so 1 minus r. So that's the formula for Sn. Now it says given that mod r is less than 1, write down the sum to infinity of the series. So if mod r is less than 1, then as n tends to infinity, r to the power of n will tend to 0, because when you keep multiplying a fractional value by itself, it keeps getting smaller and smaller. So the sum to infinity will be the r to the n term has gone to 0, so the top line is just a over 1 minus r. Part B, the sum of the first term and the second term of a GP is equal to twice the sum of the second and the third term in the series. So the first term is a, second one is ar, third one is ar squared. So what I got then, the first and the second, so a plus ar is equal to twice, so that's 2 times the sum of the second term, ar, and the third term, ar squared. And then I want to solve this to find the common ratio. So left hand side, a plus ar, on the right hand side is 2ar plus 2ar squared. And you see there, throughout that series, every term has got an a in. So if I divide by a, I have 1 plus r is equal to 2r plus 2r squared. So quadratic, take it all onto one side. So 2r squared plus 2r minus r minus 1. So it's 2r squared. 2r take away r is plus r minus 1. And factorising that, it's going to be 2r and r. It's got to be 1 and 1. So plus minus. So r is equal to a half, or r is equal to minus 1. And the question said, given that the common ratio is positive, find the common ratio, therefore r must equal to half, since I wanted the positive ratio. And second part is telling me that the sum to infinity is 12, so sum infinity is 12, so that tells me that 12 is equal to a over 1 minus r. Find, correct the two decimal places, the sum of the first 8 terms. So I want to find S8, so I know what R is, so I now need to find out what A is. So substitute into this equation here, sum to infinity equation. So 12 is equal to A over 1 minus a half. So 12 is equal to A over 1 minus half is a half. And then multiply up 12 times a half equals A. So A is equal to 6. Right, so A is 6, R equals a half, and I want to find what the sum of the first 8 terms are. So Sn is that. So to find the sum of the 8 terms, A, that's 6 bracket 1 minus a half to the power of n, which is 8, over 1 minus a half. And I want this value to 2 decimal places. So type in this the calculator then, fraction button in, 6 bracket 1 minus a half to the power of 8, close a bracket, over 1 minus half. That is 11.953125. So to 2 decimal places is 11.95.